of you. We continue our discussion of a theory, relations and functions. Now we are on functions. Here is a function, the greatest integer function. The symbol is x in a square bracket. X in a square bracket, the greatest integer function is the integer less than or equal to x. Now for example, the integer function of 5 is 5. Integer function of 4.9, we require an integer less than or equal to 4.9. So there is no integer equal to 4.9. Less than 4.9, the integer is 4. Integral function of 0.7 is 0. Integral function of minus 1.5 is minus 2. Integral function of minus 4 is minus 4. Now we can see, in the case of negative numbers, this point represents minus 1.5. And we are looking for the integer less than or equal to this point. So the integer is minus 2. So in the case of negative integer, there is a problem like this. Now, properties. F plus g of x is fx plus gx. F minus g of x is fx minus gx. F into g of x is fx into gx. F divided by g of x is fx by gx, but here gx must not be 0. Now this is addition and subtraction of functions, multiplication of functions and division of functions. Now the greatest integer function graph is like this. For any value of x between 0 and 1, the value is 0 only. Between 1 and 2, the value is 1. You can see the value is 1. But 2 will not come there. Integer function of 2 is 2. So that will go there. Between 2 and 3, this is how you represent the integer function. So idea, integer function is integer only. They are integer integral values 1, 2, 3, 0, minus 1, minus 2 and so on. But care must be taken about these endpoints. The right endpoint, the right endpoint, right endpoint, right endpoint, right endpoint is not included. So make sure you understand the basic idea. Now we consider another example. F of x equals x squared when 1 less than or equal to x less than or equal to 4. F of x equals 4x when 4 less than or equal to x less than 5. Now here the graph y equals x squared is a parabola. That parabola from 1 to 4, from the region 1 to 4, that parabola. Then 4x is a straight line from 4 to 5. Now this is a function because a vertical line will meet the curve only once. Now domain of f, domain means the values taken by x. It takes values from 1 to 4 and then 4 to 5. So that 5 is not included, excluded. 5, it is not taking 5. The range, values of x squared start with 1 squared. 1 squared is 1. 4 square 16. 4x 16. And then finally 5 square, 4 into 5 is 20. But 20 is not taken. So for this region 4 to 5, we have to take 4x. Now here one important idea, at the point 4, for both of these, you have the same value. At x equal to 4, the value is 16. At x equal to 4, the value is 16. That is why it is a function. Now here is another example. Gx is x cubed in the interval 0 to 1 and 2x from 1 to 2. Now you can see for the point 1, x cubed is 1 in this formula, and for the point 1, the function is 2 into 1, 2. So there is a difference. G of 1 is 1 in one situation and G of 1 is 2 in the second situation. So same value, same number 1 goes to two different areas, 1 and 2. That means it is not a function. So Gx is not a function, but Fx is a function. Now, we consider another example. Domain of Fx, given f of x equals f squared by f squared minus 1. We see that the denominator f squared minus 1 cannot be 0. So condition is f squared minus 1 not equal to 0, or x plus 1 into x minus 1 is not equal to 0. That means x cannot be plus or minus 1. So set of values of x is the domain. So domain of f is real number minus the set minus 1, 1. It is the complement of the set minus 1, 1. Now domain of fx is x cubed by s squared plus 4. The denominator s squared plus 4 is never 0. Therefore domain of f is the set of real numbers minus infinity, infinity. The range of this function is also R, because s can go from minus infinity to plus infinity. Now domain of f x equals 3x squared plus 2 by x minus 1 into x minus 2. You can see the denominator is 0 at x equals 1 and x equals 2. So the domain is the set of real numbers minus the set 1, 2. You take away the set 1, 2. The remaining will give you the domain of the function. So domain of the function is real number set minus the set 1, 2. Now we consider another example. F, the function f is given by 1, 5, 2, 8, minus 1, 0, 2. It is a linear function. Linear function means first degree. Y equals ax plus b. The question is, what is a plus 2b? Now the method is, you substitute these points. X is 1 and y is 5. So x is 1 and y is 5. You get 5 equals a plus b. X is 2, y is 8. You get 8 equals 2a plus b. Now if you subtract first equation from the second equation, 8 minus 5 is 3. 2a minus a is a, and b cancels. So a equals 3. Now if a is 3, b is 3 plus b is 5, or b is 2. So a is 3, b is 2. 3 plus 2 into 2. 3 plus 4, 7 is the answer. Now here is an important idea. If f of x is 3x minus 1, find f of 2 and f inverse 2. Try to understand the difference. F of 2 means you need only put x equals 2, because f of x is given. So when you put x equals 2, you get f of 2. So x is 2, 3 into 2, 6, minus 1, 5. But when you want f inverse 2, we have to substitute the f value equal to 2. So we have to take fx equal to 2. Then only you get the inverse. So if you put fx equals 2, you get 2 equals 3x minus 1, or 3x equals 3, or x equals 1. And that is the value of f inverse 2. So try to understand the difference between f and f inverse. In the case of f of something, you have to put that x is equal to. Then in the case of f inverse of something, you have to put f equal to that something. You get the result. Okay. Domain and range of fx equals root of 4 minus x squared. You know, when you take root, the value within the root must be greater than or equal to 0. So 4 minus x squared must be greater than or equal to 0. Or x squared on the other side should be less than or equal to 4. That means minus 2 less than or equal to x less than or equal to 2. Or domain of f is the closed interval minus 2, 2. Now when x equals 0, the f value is 2. When x equals 2, the f value is 0. So the range is the interval closed interval 0 to. Now, another example, range of fx is 3 minus 4x. X is greater than 0. So, x equal to 0 is not there. So, if you take x equal to 0, f is 3. But 3 is not included. Important. 3 is not included. Therefore, range will be, if x takes larger and larger values, it goes to negative, 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 infinity. So, range is minus infinity to 3. But 3 is not included. Open interval. So, minus infinity, 3 open. This is the range of this function. And domain is actually x greater than 0. So, all positive real numbers. This result is important. We consider set theory topics. Next class we will be going to the fundamentals of trigonometry. Now for the time being, we come to the closure of this lesson. We have been discussing set theory, set relations and functions. In the next class, we will move to trigonometric basic results. My aim is to give you simple ideas, basic ideas, then expand. In due course of time, we will discuss all important problems. We will go up to the level of IIT in the long run. Now, for the time being, the basis. Now, we wish all of you to understand the subject and also pass this information and messages to your friends so that all will be benefited. And let us see, mathematics is simple. We will come to it. Thank you.